Hi, hello viewers. Welcome to NAGA'S Gurukulam.
In this lecture video, we will see how to simulate a Verilog program for a 4-bit ring counter. So, to design a 4-bit ring counter, we are using D flip-flops and we will simulate the program. So, to design a 4-bit ring counter, we need 4 D flip-flops like this, in which the output of one flip-flop is corrected as output input to the next flip-flop. So the last flip-flop output is corrected as input to the first flip-flop, and we have preset input for the first flip-flop which we need to set, and we have clear inputs for the rest of the flip-flops. So this is the design of the D flip ring counter using D flip-flops. So this is the output. So let us open model sim, and first let us create a new project. So let me create a new project, and let me call it as a ring counter, and let me create a new file, that is D flip-flop. First we have to write a program for D flip-flop, and then we have to use the D flip-flop to write the program for ring counter. So first let me write the program for D flip-flop. So here there are 4 flip-flops, right? So I'll write a program for D flip-flop first. So module, so every Verilog program starts with keyword module. So module D flip-flop, DFF is the name of the module which I am going to give. So for the flip-flop I have two outputs, Q and Q bar, and input D. So I'll give D comma Q bar as QB, and let me have clock input and preset input for the D flip-flop. So let us declare input D clock preset input. Next let us declare outputs. So output Q Q bar QB, that is. So next, since it is a flip-flop, initially we have to give some state output. So initially begin, I will give Q as 1 apostrophe B 0, and Q bar as 1. So initially, because we have to give the previous states, initially I am giving Q as 0 and Q bar as 1. Okay, and end. Next I am going to write the program using behavioral modeling. So I will use always statement. So always at the rate of clock, that is negative edge of clock, I am going to perform the every operation of D flip-flop. All the operations begins at negative edge. So begin if the preset input is 1, that is if preset means if the condition is true, that is preset is 1, I am going to set my Q to 1 and Q bar to 0. So begin Q bar equal to 1 apostrophe B 0 and Q to 1. Okay, let us declare Q first. Q 1 apostrophe B 1 and Q bar to 0, 1 apostrophe B 0. So now if the preset input is given, my flip-flop will be set. My flip-flop output will be set. We have to use this compulsory because the first flip-flop has to be set at the beginning. Next, else, so if the preset input is not 1, then I am going to perform the ordinary operation of D flip-flop, then begin. So the characteristic equation of D flip-flop is D equal to Q. So I will write the same thing, else. So begin Q equal to D, which is the equation of D flip-flop. So this is a simple D flip-flop. Q bar equal to complement of D and end. So this is the end for else block. Next I have to give an end to the else begin part of always. So there are two blocks. If block 1 begin and else block will be on begin, and always block 1 begin and at the one end, and the end will give end module. Now let us simulate this D flip-flop program. So save the program and we will compile the program. So we have got one error. Let us check what is that. So the mistake here is the outputs which we are using in the always block should be declared as registers. So that is the mistake. Let us include one line. So register, so whatever the variables which we are using in always block and initial blocks, these two Q bar should be declared as register. So now I think everything is fine. Let us save and compile it again. Now it is successful. Let us now check the output of D flip-flop. So this should be working properly. to get the ring counter. So first we have to simulate the program for D flip-flop. Once it is compiled and output is okay, then only we should go for designing of ring counter. Since we are using D flip-flops in ring counter, first D flip-flop should be simulated correctly or properly. So let us give D some clock of period 200. Okay, now I'll give the clock input. So first I will make the preset input as 0. So if the preset input is 0, the flip-flop works ordinary. Our output Q equal to D, you can see in the various cases. Q is 0 and Q bar is 1. So you can check it. So whenever the clock is at the negative edge, our output Q is equal to D and Q bar is complement of D. So this is satisfied. Let us check whether our preset input is functioning well or not, because preset is important here. So once we give preset to 1, so you should see that our output is 1 irrespective of whatever the D or clock. If preset is given 1, your output Q will be 1 and Q bar will be 0. So this is satisfied, and let us go to the design of this. So to set this first flip-flop 1, output 1, we are using this preset input. So you can check here, when preset is 0, output is Q is equal to T at the negative edge and Q bar is complement of Q. And when preset is 1, irrespective of whatever may be your clock and D, the output is set to 1. So let us end the simulation and now write this code for ring counter. So either you can create a new file or you can write the ring counter program in the same file. So I will write it in the same file. So module, so in the same project, in the same file I am writing, you can include another file also if you want, there is no problem. So module ring counter. So our ring counter has, so let us see what are the inputs and outputs we have. So our ring counter has clock input and it should give the outputs and preset inputs. So we have output out and clock, only one output, that is out, which is a 4-bit, and clock and preset are of single bit. So input clock comma clock, it is single bit, and preset is of 4-bit because we have 4 flip-flops, and output is also 4-bit. So each flip-flop we have one preset input, and each output we are taking across each flip-flop. So input 0 to 3, since we have 4 flip-flops, 3 to 0 preset. Since every D flip-flop which we have created earlier has preset input, so we have 4 preset inputs. I have not taken clear inputs in my D flip-flop, you can observe that it is not needed. So output, again we have 4 bits, so 3 to 0 out. Now we have to use this D flip-flop 4 times. So let us copy the same D flip-flop here because we have to use 4 times, and let us name the first flip-flop as D1. The first flip-flop. So this is the output of, so first is the input, and this is preset 3, preset 3. Next, similarly, so the input to the last flip-flop is the output of first flip-flop. So this way we have taken the feedback. So from right side we are taking, this is Q1, Q2, Q3, Q4. So Q4, so Q1 flip-flop output acts as input to the Q4. So that is what we have written here. So the output of rightmost flip-flop is acting as input to the first flip-flop, which we have taken as D4, Q4, Q4 bar. Next, similarly, the second flip-flop we have this flip-flop. So this is Q4, so Q4 acts as input to the next one. So D2 has input. In place of D we are putting Q4, and the outputs of third this flip-flop is Q3, QB3, and preset input is 2. Similarly, the output of this flip-flop will act as next for the D3 flip-flop. So D3, so here the output Q3 acts as input to this, so Q3. Next we have this Q2, QB2. This is clock and this is preset 1. So similarly the fourth flip-flop I will give it. So let this be D4. The output of earlier flip-flop is Q2, so Q2 acts as input to this, and the outputs are now Q1, QB1, and the preset is 0. So this is the circuit diagram as per the design, and now I will assign outputs. So assign out equal to Q4, Q3, Q2, Q1. Now end module. So let us save this program, and so I can clearly see the output of one flip-flop is acting as input to the other flip-flop. So D4 input. So let us now simulate. Let us now compile the program. Once it is successfully compiled, we will start the simulation. In the work, let us see ring counter module. So here it is, and let us now click on OK, and let us now add all signals to the wave. So once we have added all signals to the wave, we should now be careful, since the first we have to give the clock, and we have to give the preset input, since the first flip-flop has to be set to 1, because in the truth table we can see that initially the first flip-flop has to be set to 1 and others have to be set to 0. So 1 0 0 0. So to do this we have to set the first flip-flop to 1. So I will give force and 1 0 0. So now let me run the program. So once it is run, we can see 1 0 0. So immediately we have to not run the program. So next step, immediately what we have to do is we have to set the preset. Now the first flip-flop is set to 1, and now others, all the preset has to be given 0, others will not get the correct output. So initially we have to set the first flip-flop output to 1, so we are giving 1 0 0. Immediately we have to make all the preset inputs to 0 and run the program. So if you are not doing this, you will not get the program correctly. Now you can see that the 1 is shifted like a ring, 1 bit as per the truth table. So like this we are getting the output. You can see that 1 is shifted like a ring.
Thank you. Thanks for watching this video. Please subscribe to NAGA'S Gurukulam. Thank you.